This is Jacob's Algebra, Chapter 12, Lesson 4, Part 2, Adding and Subtracting Square Roots. We already worked through the first couple of problems in Set 2. The last one we did was number 6, which is just like number 12 that I assigned as homework. Remember to be very careful with your calculator when you are doing these problems, because what you think you are telling the calculator to do may not be what you are actually telling the calculator to do. Okay, let's move on, and we're going to do number 7. This is not a calculator problem. Number 7 says simplify. So you're going to leave everything in radical form. Now I want you to notice when you see these problems that you are not multiplying, you are adding or subtracting. So let's look at part A. Part A is 7 plus 2 square root 5 plus 1 plus 3 square root 5. Okay, notice this is a plus, not a times. We're just adding. One thing that you might want to do when you see the problems like this is rewrite them in horizontal form. In vertical form, so that you have 7 plus 2 square root 5 plus 1 plus 3 square root 5. Then it's easy to see you add your numbers to your numbers. 7 plus 1 is 8. We have 2 root 5s. We get 3 more root 5s. That means that we have 5 root 5s. Now you could also, because addition is associative, that means that you can change what's grouped together. You can also just look at this and say, oh, 7 plus 1, that's 8. 2 root 5 plus 3 root 5, that is 5 root 5. So you don't have to rewrite it this way to solve the problem. It's just something that might be more convenient for you and make it easier for you to know what you need to add together. Let's look at part C. Part C is 18 plus root 18. And then we're going to add 2 plus root 2. Okay, now this one, you can see our roots are not the same, but 18 can be simplified. There is a square number that is a factor of 18. We can write it as 9 times 2. We could write it as 3 times 6, but that would not be useful because neither 3 nor 6 is a square number. Remember, we're looking for square numbers that are factors. Since 18 is 9 root 2, 18 is 9 times 2, we can take the 9 outside of the square root, which makes that a 3. And then we leave our 2 inside the square root. We have 3 square root 2. So 3 square root 2 is the same as 18. I can rewrite this 18 plus 3 root 2. And then I'm going to add 2 plus root 2. 18 plus 2 is 20. 3 root 2 plus another root 2 is going to be 4 root 2. So we have 20 plus 4 root 2. The other way we can do this is just looking and saying, okay, 18 plus 2, that is 20. 3 root 2 plus another root 2, that is 4 root 2. So you don't have to write it in this other format. It's kind of like my grid method. I like the grid method because it keeps everything organized and you make sure that you add together, well, in the grid method, that you multiply together what you need to multiply. For this makes sure that you add what you need to add. Okay, let's look now at part E. Okay, 7E you're going to have to be very careful with. We have 5 plus 5 root 2 minus 4 plus 4 root 2. Now, we have the same radical in each of these. What you have to be very aware of is this negative sign in the middle. That negative sign does not just apply to the 4. It also applies to the 4 root 2. What I recommend doing anytime you have a minus in front of a parentheses is go ahead and change that minus to a plus and then flip the sign of everything inside your parentheses. Then you don't have to worry about remembering that that negative applies to everything. You've already taken care of it. So I'm going to write this out both ways. We have 5 plus 5 root 2. We have negative 4 minus 4 root 2. 5 minus 4 is 1. 5 root 2 minus 4 root 2 is just a root 2. Or we can do this and just say 5 minus 4 is 1. 5 root 2 minus 4 root 2, that's just 1 root 2. So it's 1 plus root 2. Be very careful with this when you are subtracting something that's in parentheses. That minus applies to everything in the parentheses. It doesn't mean necessarily that everything in the parentheses is negative. What it does mean is that you need to flip the sign of everything in the parentheses. So let's do one more. Let's look at 7f. 7f is 75 plus root 75. And then we're going to subtract 27 plus root 27. Okay, these radicals are not the same, but let's see if they can be simplified. 75, what are the factors of 75? Well, we've got 1 and 75, that's not useful. We also have 3 and 25. That one is useful because 25 is a square number. So I'm going to write this as 25 times 3. We know that the square root of 25 is 5, so we can rewrite this 75 as a 5 root 3. So this is 75 plus 5 root 3. And then we have 27 plus square root 27. The factors of 27 are 1 and 27, which isn't useful, or 3 and 9. 9 is a square number, so let's write this, 9 times 3. When we take the square root of 9, we get 3, and then we still have a 3 left behind. So this is 27 plus 3 root 3. Remembering we're subtracting everything in this second parentheses, so I'm going to change my minus to a plus and flip my signs. Remember to do this because this will bite you. People have problems with this all the way up into differential equations. They have problems remembering to distribute that negative. If you go ahead and do it at the beginning, it won't cause you problems. So I'm going to rewrite this 75 plus 5 root 3 and then negative 27 minus 3 root 3. What is 75 minus 27? That is 48. And then 5 root 3 minus 3 root 3 is going to be a positive 2 root 3. Or we can just look at it this way and say 75 minus 27 is 48. 5 root 3 minus 3 root 3 is a positive 2 root 3. Just remember when you have that negative, change it to a positive and then flip your signs. That will take care of distributing the negative for you. So that was number 7. It's just like number 13 that I assigned for homework. Let's look now at number 8. Number 8 says, if possible, simplify. Since it says if possible, that means you run into the possibility of having some of these that don't work. If it doesn't work, you say not possible. Okay, so let's look at a couple of these. Part A, we have 4 root x plus 16 root x. Okay, we have a root x and we have a root x. That's the same kind of thing. That means that we can add these. We have 4 of these root x's. We get 16 more of them. That means that we have 20 of these root x's. Okay, let's look at part B. Part B is x root 4 plus x root 16. Now, these, we have different things in our roots, but notice that these are both square numbers. The square root of 4 is 2, so our first term becomes 2x. The square root of 16 is 4, so our second term becomes 4x. 2x plus 4x is 6x. Let's jump down to part E. Part E is 64 times the square root of xy, and then we add the square root of 64xy. Let me make that, well, you still can't really read that. We can't do anything with this xy here or over here, but 64 is a square number. It's the square of 8. So we can rewrite this as 64 square root xy. We pull this 64 out of the square root to have 8 times the root of xy. 64 of these square root xy's plus another 8 square root xy's is going to give us 72 times the square root of xy. So we could actually simplify that. Okay, let's look at part G. Part G is square root of 28x, and then we're going to add the square root of 7x. Well, 28 does have a square factor. We can write it as 4 times 7. So 28 can be written as 2 root 7x because we can take the 4 out because 4 is a square number. The square root of 4 is 2, but the 7 is left behind and so is the x. So we have 2 times the root of 7x plus another root 7x And that's going to give us 3 of these root 7x. Let's do one more. Let's look at part F. Part F, we have square root of x minus the square root of y. We can't do anything with this. These are not the same kind of thing. We can't factor x, we can't factor y, so we can't simplify either one of these. So this is just going to be not possible. So that was number 8, which is just like number 14 that I assigned for homework. Okay, let's look now at number 9. Number 9 says, solve each of the following equations for x. Leave your answers in radical form, but simplify them as much as possible. This means don't punch square root 10 into your calculator to find out what square root 10 is. If you get square root 10, then square root 10 is your answer. You just leave it written as square root 10. Okay, so let's look at 9b. We have x plus the square root of 9 is equal to the square root of 19. Well, we want to get the x by itself. Since we're adding a square root of 9 to it, let's subtract a square root of 9 from both sides. And so what we have is x equals square root of 19 minus the square root of 9. 9 is actually a square number, so we can take it out of the square root. The square root of 9 is 3, so we can write x equals the square root of 19 minus 3. Make sure that you don't get this minus 3 underneath your square root because it does not belong under there. Okay, let's look at part D. Part D is square root of 144 plus x is equal to square root of 64. I'm going to go ahead and take care of my square roots. The square root of 144 is 12. The square root of 64 is 8. I can subtract 12 from both sides. And then I'm left with x is equal to -4. Let's do one more for number 9. Number 9, part F, says the square root of 5 times x, the x is not in the square root, minus the square root of 45 is equal to the square root of 125. Well, the square root of 45 and the square root of 125 can both be simplified. 45 can be written as 9 times 5. 125 can be written as 25 times 5. Is that right? Yeah, 25 times 5. So when we take the square roots of these numbers, the square root of 9 is 3, and then we're left with the 5 in the square root. The square root of 25 is 5, and we're left with the 5 under the square root. So we have the square root of 5 times x minus 3 times the square root of 5 is equal to 5 times the square root of 5. So we want to get our x term by itself. To do that, we're going to add 3 root 5 to both sides because that will get rid of the one that we're subtracting. So we end up with the square root of 5 times x is equal to 8 square root 5. And now to get the x by itself, we need to divide both sides by square root 5. So when we do that, these square root 5s cancel, those square root 5s cancel, and we're left with x is equal to 8. So this was number 9. It is just like number 15 that I assigned for homework.